the triangle inequality, we're basically using the concept that we learned in elementary school about triangles, that two sides of a triangle have to be bigger than the third side when they added together. They can't be the same or less than to make a triangle, and we'll talk about that here shortly. And we're just going to use it to write inequalities. So the triangle inequality theorem states the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. So if I add any of these two sides together, for example, this first one, I'm adding AB and BC, they have to be longer than AC. The second one, if I added AB and AC together, the blue and the green, they would be longer than the red one, BC. And if I added the third case, BC to AC, those would have to be longer than AB by itself. Otherwise, it wouldn't be a triangle. I mean, if you think if I had a side length of 2 and a side length of 4 and a side length of 6, if I tried to make that into a triangle, if I connected the 2 and the 4, they'd be the same length as 6. It wouldn't be able to make a triangle. If I did the 2 and the 4, 6 would lay right on top of it. It'd be a straight line. I couldn't make a triangle with that. And if I tried to, it wouldn't connect. Okay, so two sides put together have to be bigger than the third side. So let's use that. Could I form a triangle given the side lengths here? If not, explain why or why not. So basically, I could look at every single one of those cases to see if two sides added together are bigger than the third side. But really, the only case I need to look at is the two smallest. See if the two smallest, here and here, add up to be bigger than the third side. So if I take 6.5 plus 6.5, would that be bigger than the third side? I got 13. Is that bigger than 14.5? No, it's not. So I know that this cannot make a triangle. That would not make a triangle. I wouldn't be able to connect them all to make a triangle. Because any two sides have to add up to be bigger than the third side. What about this one? I think this one works. Okay, and I could check every case. In this case, I can kind of see it. But to be sure, I would take the two smallest, add it together to be bigger than the biggest. I would take the biggest and the smallest, so 7.2 plus 5.1, and see if that's bigger than the third side. And then take the two biggest, so 6.8 plus 7.2. See if that's bigger than the third side. Well, that one's obvious for sure. So all these work out. I don't even really have to add them. I can just look. I know that this is bigger than this. I know that this is bigger than that. And I know that that's bigger than that. So I know this is a triangle. I don't even have to add them to find the exact lengths. I can just tell by looking. Okay, so two sides have to be bigger than the third side for every situation in a triangle, for it to be a triangle. How about this? In triangle PQR, so I have a triangle for sure. PQ is 7.2, QR is 5.2. Which measure cannot be PR? Cannot be PR. So let's visualize this. If I have P, Q, 7.2, and R, Q to R is going to be 5.2. So which of these could it be? Well, I think 7 works, right? If I had a side length of 7, I could take, 7 plus 5.2. I basically just check the two smallest sides. Would that be greater than 7.2? Yep. 9 would work. Well, if I thought about 9 being on the triangle, no, that would be the biggest side. So let's try the two smallest. 5.2 plus 7.2. Is that greater than 9? Yep, that works. How about 11? That would be the biggest side. So I'm going to check the two smallest here. 5.2 plus 7.2. That be greater than 11? Well, 5.2 plus 7.2 is 12.4. That's greater than 11. Yep, so that works. Uh-oh, what do we notice? It's not going to work for 13, because 13 would be the biggest side. And we just said 5.2 plus 7.2 is 12.4. So 12.4 is not greater than 13. So we could not have a side length of 13 and have a triangle. They wouldn't all connect if I had that. So the rest of the cases, I could have a triangle, but not the last one. Okay, last thing. It says, find the range of possible measures of x if each set of expressions represents measures of the sides of a triangle. So these are 3 sides on a triangle. So I'm still thinking any 2 sides add up to be bigger than the third side. So the one thing I can do is I can just cover every single case. So basically, if I added x plus 4, two sides, it has to be bigger than the third side. Next case, x plus 6 has to be bigger than the third side, 4. And the last case, 4 plus 6 has to be bigger than the third case, x. And if I simplify all these, subtract 4 from both sides, I get x is greater than 2. Here we subtract 6 from both sides, x is greater than negative 2. And here I add my 10, 10 is greater than x. Well, if I think about it, can I have a negative length? No. So this does not work, because I could not, x is greater than negative 2, so I'm saying negative 1 works? No, that doesn't make any sense. I can't do that. And then for the rest of it, let's write it as one inequality. So these two work. So it has to be greater than 2, but less than 10. It makes more sense if I write it this way. Put the x in front. X is less than 10. So my side lengths have to be greater than 2 and less than 10. And I want to write this as one inequality. So I write my smallest measure first, 2. And it's pointing to the 2 here if I look. 2 is less than x, which is less than 10. So any of my side lengths for x could be anywhere in between 2 and 10. And if I think about this, the quick way to do it is if I'm just missing the one side length. All I have to do is subtract my 2 lengths to cover the smallest side length I could possibly have, and add my 2 lengths to cover the biggest possible side. And then I write it as an inequality. So either way works. I can cover each scenario like I did in the first part, or if I'm just looking for that one side is x, I can just think about it that way. Okay, when I look at 2, I can't do the easy way, the shortcut. I have to set up all my inequalities. So I take 2 sides, so x plus 2, and I take the other side, x plus 4, and I'm saying that they're greater than x plus 6. I'll put these in parentheses so we can see that I'm doing the 2 different sides. And then I got to do every single scenario. So I got x plus 2 plus x plus 6 now instead. It has to be greater than x plus 4. And I'll put those so we know those are the different sides. And then my last case would be what? X plus 4 and x plus 6. And that would have to be greater than x plus 2. Okay, and then let's go through and solve all these. So I don't really need my parentheses when I go through and solve, but here I got 2x plus 6 when I combine like terms is greater than x plus 6. Get my x to one side, and we move the rest of it on the other side. So I got x is greater than 0. Okay, let's look at the green one now. So combine my x's, so 2x. 2 plus 6 is 8, is greater than x plus 4. Get my x to one side. Move everything else to the other side. And now I got x is greater than negative 4. And lastly, combine my x's, 2x plus 10 is greater than x plus 2. Get my x to one side, so we subtract x. And subtract the 10, subtract the 10. So I have x is greater than negative 8. So now I keep any scenario that's going to give me positive side lengths, because I can't have negative side lengths. Well, x is greater than negative 8. If I plug in negative 8 anywhere into any of these, I get negative side lengths, don't I? So this one doesn't work. X cannot be greater than negative 8. What about x is greater than negative 4? Well, if I plug in negative 4 here to a couple of these, I get either a negative side length or a side length that's 0. So that one doesn't work. So here's my only case that works. X is greater than 0. And that's actually my answer. If I plug in any number greater than 0, I get sides of a triangle that work. For example, if I had plugged in 6, I can plug in 6 for everything. Well, that would give me a side length of 8, a side length of 10, and a side length of 12, and that would work. So basically, any number over 0 would work. So sometimes I might have an inequality like I did in number 1 here, where it's actually a range of numbers, or sometimes I might have one like I did in number 2, where I might just say, well, anything over 0 would work, or anything over a certain number would work. So you just got to check at each case like that. Set up all 3 inequalities and solve, and take away the ones that are negatives. There you go, a little bit with your triangles.